container. Do you have one example of that, Greg?
There, again, I don't say there isn't a container. Gravity is a container.
Sacred, you want to take this?
Yo, Pierre, you want to come out here?
Like Floyd Mayweather with this shit, man.
He's always fucking Floyd
Mayweather. Fridays on Twitter. Shout out to them. They're a bunch of legends.
Qualified surveyors, Walter Bislan and Jesse Kozlowski, did their own measurements to check if reciprocal zenith angles is a thing. Here's a diagram. If the Earth is flat, then these angles will sum up to 180. If the Earth is a globe, then there'd be more than 180.
So they're not even directly measuring it either then?
They're all comparing it to the ellipsoid model, and that's what the corrections are based on. That's what I was trying to get at.
Well, yeah, but the ellipsoid model is built by those measurements.
That's hella circular, but like...
Determined that all the sum of the reciprocal zenith angles came to more than 180 degrees, which would say that the surface of the Earth is not flat.
If you have, what I was going to say before is the corrected column, all equals 180. So you have a bunch of measurements that aren't exactly 180. They're all about some a little bit above, some most below, right? And you have this correction column where they all equal 180. So I'm trying to figure out what you do to the actual measurements to get them to all equal 180 that isn't applying them to this ellipsoid coordinate system that would do that exactly.
The survey was that there is a deviation of 1.4 degrees, which meant that there is curvature. It didn't sum to 180, it summed to more than 180. The only way that can happen is if the surface of the Earth is physically curved.
You're not actually directly measuring the curvature itself. Again, you're measuring the amount of dip angle, and then you're assuming that the dip angles and the way that things are dropping is due to the spherocity.
What he did was shown on Walter Bislan's page where he analyzed it and did the maths to also show that refraction is taken into account. And even without refraction, that it shows the Earth is curved. If you add refraction, which would lift the image up.
For the measurements that you're making optically through your theodolite, do you take refraction into account? And specifically, did the arc of the Apparel take into account refraction? Is refraction a factor in any other measurements?
So yes, particularly in the zenith angles. Horizontal refraction is a very different impact than vertical angle refraction.
Well, I mean, I'm reading from, like, let's see, page 206, and it says, corrections demanded by the adjustment of the base net measurement of this arcsecond and the same as derived from the statesman adjustment of another arcsecond. And then it goes into persistent lateral refraction also has a share in producing the above result. And then it goes on to denote the formula that they derived to calculate that refraction. Isn't it odd that we're claiming that the optical measurements we're making above this really tiny threshold are actually persistent above and beyond what we can calculate for, like, refractive indexes?
Yeah, you're right. No, you make a strong point. So there's no further conversation here.